Hello viewers, welcome yet to another lesson of mathematics for the upper basic level, and this would be our lesson 3. And if you have been following on our lesson 1, we have looked at the vocabulary, we have gone as far as changing from words into expressions, and then on the lesson 2 as well, we have gone as far as the expansion of brackets or the distributive properties. Like, we have looked at things like if I have 2 into x plus 2, where if we want to expand these brackets here, we simply need to distribute the 2 outside the brackets to all the terms that are inside the brackets. So this would lead us to 2 times x plus 2 times 2, and that will simplify to 2 times x is 2x plus 2 times 2 gives you 4. Now, we have also looked at something like when we have negative into x minus 2. Remember we said if you only have a negative outside the brackets, it is actually a negative 1 into x minus 2, which means we are going to use the negative 1 to expand the brackets, and that will lead us to having negative 1 times x minus negative 1 times the 2, and that will give you negative 1 times x is just negative x, because we can actually ignore the 1, and if you multiply 2 negatives together, they lead you to a positive, and 1 times 2, that gives you 2. That was where we stopped at our last lesson. Now today we are going to pick up from there and move on to combining like terms. Now that is our lesson for today, and as usual, I always say this, get a pen and a paper by your side as we move along. Now, before we can combine like terms, of course, first we must know what like terms are. Now, like terms are terms in an expression that have the same variable raised to the same power. Now, there are two key things there. One, they must have the same variable, and then secondly, the variable also has to be raised to the same power. Now you have examples here. If you look at 6x and 2x, the variable there is x for both of them, and also the power of the variable is 1 in both cases. So you can call 6x and 2x as like terms because they contain the same variable, and the variable is also raised to the same power. Likewise, 5y and 8y, same variable, same power. They are also like terms. And then you have 4x squared and 7x squared. Again, if you look through that, the same variable x, and then the variable as well have the same power. They are all squared. So again, that will qualify as like terms. Now, if I have negative 3y and 9y, these also will qualify as like terms because if you look through, they have the same variable, and the variable is also raised to the same power. Now, the coefficients do not matter. Whether the coefficients are the same or not, that does not matter here. Your interest here is on the variable. Once they are the same, and the power of the variables are also the same, then they are like terms. But if you look at the other side here, these terms are not like. Because if you look at 6x and x squared, although the variables are like, they are the same, but their powers are different. So therefore, they cannot be called like terms. Remember we said for terms to be like, the variable must be the same, and then the power of the variables as well have to be the same. So this cannot qualify as like terms. The same thing like 5y and 8 only. We know that 8 can be written as 8y to the power 0. We have gone through that through our previous lessons. So 5y, the power of the y there is 1, and the power of this other y is 0. So because the powers are different, they don't qualify as like terms. Similarly, 4x squared and x to the power 4. Same variable, yes, but the powers are different, so they won't qualify as like terms. So therefore now we know that like terms must contain the same variable, and then the variable also must be raised to the same power. Only then can you call them like terms. Right. Let's see if we can use that explanation and try to answer this. It says, identify all of the terms that are like 5y. Now, if you want to get the answer easily, just look at the term 5y and focus on the variable. The variable there is y. So anyone with the same variable, and by the way, the power to that variable is also 1. So any term here with the same variable y raised to the power 1 will be like 5y. And looking through very carefully, you see 18y will qualify because the same variable to the same power. 8y also qualifies. Same variable, same power. And even negative 1y qualifies because, again, same variable, same power. Remember I said the coefficient does not matter here. So all these three are like 5y because they all contain the same variable raised to the same power. Now here's another one. Identify all of the terms like 8x. Now look through these options here. 5x. Do we think 5x is like 8x? Let's investigate. The variable in 8x is x, and in 5x also the variable there also is x. That's one qualification. How about the powers? The power in 8x is 1, and the power of the variable also in 5x is 1. So therefore 5x and 8x are alike, so this will qualify. How about 4x squared? Let's look at the variables. Are the variables the same? Yes. This is an x, and this is an x. But are the powers also the same? This is power 2, and that is power 1. Those are different powers, so we cannot call 4x squared as like 8x. So that is out. What about C, 8y? Do we have the same variable there, or the same variables? That is y, and that is x. Different variables, so they don't qualify. How about D, 8? You know, again, that 8 is 8x to the power 0. Can be that. Same variable, yes, but the powers are different. So that also won't qualify as a like term to 8x. And then finally, E, negative 10x. Same variables, same powers. So that 2 will qualify as like terms. So the only terms here that are like 8x are 5x and negative 10x. Those are like 8x rather. Again, identify all of the terms that are like 8xy. So this time our expression have two variables, x and y. So you have to look through here and see which of these terms have the same variables as x and y. And clearly, it's only 3xy and negative 10xy. Now, be careful of b. 4x square y. I know it contains the same variables just like xy, true, but the powers of x are different. So therefore, that disqualifies b, leaving C and E as the only correct options here. Again, let's identify all of the terms like 2y. So now we can go through this quick. I can go through this quickly with you. 51y will qualify because the same variable, same power. 2w will not qualify, different variables. 3y also qualifies. Why? Because the same variable, the same power qualifies. 2x cannot be because different variable, but negative 10y also qualifies, same variable, same power. So all these are like 2y. Then again, let's identify all of the terms like 14x squared. Again, if you go this, or if you look through this quickly, 5x won't qualify because although it's the same variable, but the powers are different. 2x squared would qualify because same variable, same power. That would work. C is out because the variables are different. So that doesn't even count. D, 2x, same variable, but different powers, doesn't work. And then E, you have negative 10x squared, same variables, same powers, so that will qualify as like. Right. Moving on now to actually combining the like terms. Now we should know one thing. If terms are like, they can be combined. It means they can be added, they can also be subtracted. But if they are not like, of course, we can't do that. Now, for example, you have 6x plus 3x. Now, if you look at those two terms, 6x plus 3x, are they like terms? Yes, they are, because they contain the same variable raised to the same power. So we know they are like terms. And as far as they are like, it means we can add them. And to add those two terms really is easy. All you do is add the coefficients and then just take one of the variables. Now the coefficients here are 6 and 3. So if you add those two, they give you 9, and just take one of the variables. So in the end, 6x plus 3x will end up being 9x. Now, the second example here we have 4 plus 5 into x plus 3. Now here we must refer back to our previous lesson where we had to expand the brackets. So we know that this 5 outside the bracket here is going to be distributed over all the terms inside the brackets. But the 4 just comes down. So you multiply the 5 by the x, and also multiply the same 5 by the 3. So that in the end you get 5 times x will give you 5x, plus 5 times 3 will give you 15. Then if we look at what we have now, we have 3 terms there. But do we have any of them being like? Yes, we do. 4 and 15 are like terms. We know that now. So because 4 and 15 are like terms, it means they can be combined. But the 5x is different. So it just comes down. And when you add 4 plus 15, you get 19. And 5x plus 19, the 2 terms here are not like. So because they are not like terms, we cannot add them. That becomes our solution. You cannot add unlike terms. Then the third example we have there, 7y minus 4y. First, we need to determine, are they like terms? Yes, they are like terms because their variables are the same, and then the powers to the variables are also the same. So they are like terms, so we know we can combine them. And again, to subtract them, just like we did with the addition, subtract the coefficients, that is 7 minus 4, and then just take one of the variables. And 7 minus 4 gives you 3, so you have 3y as your answer. So 7y minus 4y will end up being 3y. Now, this is important. Notice that when combining like terms, you add or subtract the coefficients, but the variable remains the same. That's very important. You only add or subtract the coefficients, but the variables remain the same. If it is x, it remains x. If it is x squared, it remains x squared. They don't change. Here we have 2 questions. And you can be working this along with me at home. We have 8x plus 9x. Now, first, we need to determine whether they are like terms. And of course, 8x plus 9x are like terms because they contain the same variable to the same power. So these are like, which means they can be added. And like we said previously, to add like terms, all you do is just add the coefficients, which are 8 plus 9, and then just maintain the variable, right? And that leads you to 8 plus 9 will give you 17, and you get 17x. So in the end, 8x plus 9x will end up being 17x. You can actually also see it this way. You have 8 x's, and you have another 9 x's. If you have to combine them, you will end up having the same 17 x's. Works that way as well. Now, let's try something like that with the second example, or the second question there. 7y minus 5y. Again, first question always, are they like terms? Yes, we can see that they are like terms. Same variable, same power. Therefore, we can subtract them. Again, subtract the coefficients, 7 minus 5, and maintain the variable. Now, 7 minus 5 obviously gives you 2, or 2y. Or again, look at it the other way. You have 7y's, and you remove 5y's from there, you will be left with 2y's. Works fine. Now I'm thinking, I hope you are trying this now. You have 6 plus 2x plus 12x. Now walk through this and see what you arrive at before I start with you. Look at the 3 terms very carefully. We have 6, we have 2x, and we have 12x. Right. I believe you have gone far by now. First, are all the three terms like? 6, 2x, and 12x. Now, clearly we can see the 6 is different. But the 2x and the 12x are like because they contain the same variable to the same power. So we can add those two. But the 6, because it's different, cannot be added. So it just comes down. 6 plus. Now, if you're going to add 2x plus 12x, you add the coefficients, so you get 2 plus 12 and maintain the variable. And that ends up giving you 6 plus, if you add 2 to 12, you get 14, 14x. Now, 6 that properly gives you 6 plus 14x. Now, if you look at 6 and 14x, these are not like terms. So therefore, you can't add them. So that is as far as we can go. Now, how about the second question? 7y plus 7x. Always, before you start calculating, determine first, are those two terms like? And clearly we can see the 7y, the variable is y, and the 7x, the variable is x. Those are two different variables. So these are not like terms. And when terms are not like, we cannot add them, also we cannot subtract them. So these two terms cannot be added. So the answer to 7y plus 7x would be 7y plus 7x. You can't add them because they are not like terms. Right. Now look at that solution there and determine whether 11x is the correct solution to 8x plus 3x. First question is, can you add those two? Meaning, are they like terms? Yes, they are like terms. If you add them, do you have 11? Yes, 8 plus 3 gives you 11. So therefore, this is a true statement that 8x plus 3x will definitely give you 11x. So that's correct. How about that? 7x plus 7y being equal to 14xy. Now, is that a true statement or a false statement? Now, first question is 7x and 7y, are they like terms? Clearly, they are not like terms because they contain different variables. And what did we say? If terms are not like, you can't add them. So therefore, 7x plus 7y can never lead you to 14xy. So this is a false statement. It's not correct. You cannot add those two. Now, how about 4x plus 4x? Those that lead you to 8x squared. Now, again, first question, are they like terms? Yes, they are like terms because they both contain the same variable to the same power. So we can definitely add them. But then, if we add them, will we get 8x squared as our solution or as our answer? We know if you add the coefficients, 4 plus 4, you definitely get 8. But what did we say about the variables? What we said was, you add the coefficients, but the variable remains the same. But in this case here, the variable have changed to x squared. So definitely, this is not correct. So this is a false statement. Now, what would have made this a true statement? If 4x plus 4x, if we have simply added the coefficients, 4 plus 4, and maintain our variable, right? And that gives you 8x. That would have been a correct statement. So 4x plus 4x should lead you to 8x and not 8x squared. The variable should be maintained, shouldn't change. Again, will negative 12y plus 4y lead you to negative 8y? Let's again look at C. Are they like terms? Yes, they are like terms because they contain the same variable raised to the same power. So we know we can actually combine them. Now, if we added the coefficients, will we get the negative 8? Because the coefficients are negative 12 plus 4. Will that lead you to negative 8? Now, if you recall from our integers, definitely this will give you negative 8. So that negative 8 there is correct. How about the variable? Was it maintained? Yes, the variable was also maintained. So definitely this is a true statement. Because when they were like terms, they could be combined. We have combined the coefficients and we maintain the variable. So this will be a true statement. That negative 12y plus 4y will lead you to negative 8y. Right. Again, you have negative 3 plus y plus 5. Will that be equal to 2y? Again, ask yourself the question. Are they all like terms? If not, do we have any like terms there? Yes, we do have 2 like terms there because we can clearly see that the negative 3 and the 5 are like. So those can be combined. So that would be like negative 3 plus 5. But the y is different, so that comes down. Now when you combine negative 3 plus 5, if you add those two, they lead you to 2 plus y. But is 2 plus y the same as 2y? Obviously not. So therefore this is not a true statement because 2 plus y is not the same as 2y. And that's a mistake we can easily make, that 2 plus y is 2y, but that is not right. 2 plus y is 2 plus y, not 2y. Now, will negative 3y plus 5y also be equal to positive? Will negative 3y plus 5y be equal to 2y? Again, first, are they like terms? Yes, they are like terms because they contain the same variable raised to the same power. So we can add them. So if we add the coefficients, which are negative 3 plus 5, and then maintain our variable, obviously negative 3 plus 5 is 2, and then maintain our variable y. That makes this a true statement because negative 3y plus 5y will simplify to 2y. So this is true. Let's look at this one. And of course, this one, it requires a bit more work before we can determine whether it's a true statement or a false statement. But of course, we do have all the tools. You have 7x minus 3 into x minus 4. Since there are brackets there, so therefore we must apply our distributive property, which means we distribute the -3 over all the terms in the brackets. And that will give us 7x minus 3 times x will give you 3x. And of course, we know if you multiply a negative by a negative, it turns to positive. And 3 times 4 would be 12. There. Now, next thing is, do we have any like terms there? Yes, we do have like terms, because the 7x and the 3x are like. They contain the same variable raised to the same power. So these are like terms. And of course, we know now, if you have 7x's and you remove 3x's from there, you simply left with 4x plus 12. And that is what was given here. So this makes this a true statement. It's true. Now, how about this one? 7 plus brackets x plus 2 close the brackets, and then there's a 5 outside the brackets. Will that lead you to this? Will that lead you to 5x plus 9? Now, be mindful that the number was put at the back of the bracket, but that is the same as having that 5 in front here. So if this is going to confuse you, rewrite it as 7 plus, bring the 5 in front, into x plus 2. Maybe that makes it easier. Then again, we apply the distributive property, and that gives us 7 plus 5 by x is 5x. A positive times a positive is still a positive. And of course, 5 times 2 gives you 10. Next step is, do we have any like terms there? Yes, there are like terms. The 7 and the 10 are like terms. So those two can be combined. But the 5x is different. So you simply bring it down. And when you add 7 plus 10, that should give you 17. Was that what we had here? No. There we had 5x plus 9. So this, therefore, is a false statement. It's not true. Now, let's take this one also. 3x plus 2y plus 4x plus 12. Is that the same as 9xy plus 12? Now, let's determine any like terms there. Yes, we have 3x and 4x are like, so those can be added. So that's going to give you 3x plus 4x plus 2y plus 12. Is that the same as 9xy plus 12? Right. Now let's see. 3x plus 4x, we know now that will lead us to having 7x plus 2y plus 12. Is that the same as 9xy plus 12? Now, on the left-hand side, do we have any other like terms there? Now, clearly, there are no more like terms here. So there's nothing we can do about this side again. So this is as far as we can go. So is that 7x plus 2y plus 12, is it the same as 9xy plus 12? Obviously, they are not the same. So this, therefore, is a false statement. These are not the same. Right. Here comes another one. 3x squared plus 7x plus 5 into x plus 3 plus x squared. Now, will that be the same as 4x squared plus 12x plus 15 when you simplify? Again, let's work and see. First, if we look through, there are brackets there. So again, we must go back to our distributive property and remove or expand those brackets. And that will lead us to the 3x squared comes down plus the 7x. Then we use the 5 to expand the brackets. And now we know that 5 times x is 5x plus 5 times 3 is 15 plus the x squared. Just comes down. Will that be equal to 4x squared plus 12x plus 15? Now let's see. Any like terms here? Clearly we can see 3x squared and x squared are like, so they can be combined, and that gives you 3x squared plus x squared. Then also, the 7x and the 5x are also like. So they too can be combined. So that will give you 7x plus 5x, right? And of course, the 15 comes down. Now, is that the same as having 4x squared plus 12x plus 15? Let's see about that. We know that 3x squared plus x squared will lead us to 4x squared. We know it's 4x squared because x squared is the same as 1x squared. So 3 plus 1 will give you 4. And also, 7x plus 5x will lead you to 12x plus 15. Is that the same as 4x squared plus 12x plus 15? Are the two sides containing the same things exactly? And you can see 4x squared plus 12x plus 12x plus 15 plus 15. The two sides contain exactly the same thing. So definitely this is a true statement. This is true. Right. We have a longer one here. Now, I hope you are taking your time to write this. You have 9x to the power 3, or x cubed, plus 2x squared, plus 3 into x squared, plus x, plus 5x. You will just simplify to give you 9x cubed, or 9x to the power 3, plus 5x squared, plus 6x. Again, let's see. You look through all that, and you see that there is a bracket there. That has to be removed using the distributive property. And that will therefore lead us to having 9x to the power 3 plus 2x squared plus, if you expand here, 3 times x squared will give you 3x squared plus 3 times x is 3x plus 5x. Will that lead us to having 9x to the power 3 plus 5x squared plus 6x. Now let's try to further simplify. Do we have any like terms there now? Yes. 2x squared and 3x squared are like. Likewise, the 3x and the 5x are also like. So they can be combined. And if you combine this, you end up having 9x cubed plus, if you add 2x squared plus 3x squared, you have 5x squared. And when you add 3x plus 5x, you get 8x. Now, is that the same as 9x to the power 3 plus 5x squared plus 6x. Now let's do our comparison. 9x to the power 3, 9x to the power 3. 15x squared, 15x squared. No, I meant to say 5x squared, 5x squared. Then you have 8x and then 6x. And that is where the trouble comes. Because now 8x is different from 6x. So therefore, all of this now is now a false statement simply because the last terms were different. So that is a false statement. Right. The length of the size of home plate in a baseball field are represented by the expressions in the accompanying figure. Now, that is the figure we have here. And we are given their lengths. This length is y. This other length is yz. Now, that is y, that is x, and that is x. So, which expression represents the perimeter of the figure? Now, the key word there being perimeter. And we know perimeter is just the distance around a figure. So if you want to find the perimeter of a figure, you simply need to add all the sides. If you add all the sides, the sum you get will be the perimeter for the figure. So let's add through this. This first length is y. Plus, this other length here is yz. Plus, this other length here is y. Plus, this other length is x. And this other length right here is also x. So that will be our expression. But then, can we simplify it any further? Meaning, do we have any like terms that we can add here? And if you look through very carefully, you realize that y and y are like terms. Also, x and x are like. So they can be combined. And if you combine them, you end up having the x's together. So you have x plus x. Then the y's together, that is y plus y. And of course, yz is different, so it comes last, yz. And if you add x plus x, remember we know x is the same as 1x. So you're actually adding 1x plus 1x will lead you to 2x. Likewise, y is 1y. So y plus y is 1y plus 1y, and that also will give you 2y plus dyz. Now, do we have any other like terms again? No. These three terms are all different. So they cannot be added. So this is as far as we can go. So the perimeter for this figure would be 2x plus 2y plus yz, which is option D here. That will be the perimeter for that figure. So we look at this other one here. It says find the perimeter of the octagon. An octagon is just an 8-sided figure, or a figure that has 8 sides. That's an octagon. And if you count the sides here, you have 1, 2, 3, 4, 5, 6, 7, 8 sides. That's why it's called an octagon. But all we are interested in here is finding the perimeter. And we know the perimeter is just the distance around the figure. And so therefore, to find the perimeter, you simply add all the sides. That should be easy. So let's do that and see. The first side is x, so we add that. Plus, the second side is x plus 2. plus the third side is x plus 3 plus the fourth side is the 7th plus the fifth side is the x plus the sixth side is the x plus 2, and then the seventh side is x plus 3, and then finally our eighth side is 7. So we simply add in all the 8 sides to get our perimeter. Okay. Now, let's try to pick out our like terms there, and then we group them together. If you look through, we can clearly see that all the x's are like, because they are all raised to the same power. So therefore, you can combine all of them. And that will be x, the first one, plus x, the second one here, plus x, the third one, plus x, the fourth one, plus there is a fifth x there, there is a sixth x there. So all the x's can be added together. Now, likewise, all the numbers also can be added, because they are all like 2, 3, 7, this other 2, this 3, and this 7. All those are also like terms. So we can combine them, and that will give us plus 2, plus 3, plus 7, plus 2, plus 3, plus 7. So all we do now is do our combinations, or add them. We know x is 1x. So if you add 1x plus 1x plus 1x plus 1x plus 1x plus 1x, you are simply adding 1, 2, 3, 4, 5, 6 x's. And that will lead you to 6x. And then the numbers there, if you add with me, 2 plus 3 will give you 5. 5 plus 7 would be 12. 12 plus 2 would be 14. 14 plus 3 would be 17. And of course, 17 plus 7 will give us 24. Right. 6x and 24. Are they like terms? No. So because they are not like terms, we cannot add them. So therefore, we cannot go any further. That would be our answer. So 6x plus 24 will be the perimeter for that octagon. Now, with that, we come to the end of today's lesson. I hope you have learned a lot from that. So we're going to stop here, and then next time we meet again, we will pick up right from there. Now, in the meantime, I will leave you with this. Keep safe. Stay at home as much as possible. Let's follow the advice of our health workers. Wash our hands regularly with soap and clean running water. Avoid crowded places. Coronavirus is real and is here. We are here for you. Stay at home for us. Thank you.